In this problem, this is a 2D rigid equilibrium problem. And what we are asked to do is we are asked to determine the magnitude of our reaction forces at point A and at point B. So when we're doing these 2D rigid body equilibrium problems, we need to remember a couple of things. We need to remember that supports are going to have reaction forces. And we need to know the equations that we're going to use. We need to know we're going to use the sum of the forces in the x are equal to 0, the sum of the forces in the y are equal to 0, and the sum of the moments about some point, and I'm just going to call it O for right now, some point O is equal to 0. So these are the three equations we can use. If we have three equations, we can only solve for at most three unknowns. And when we're solving these problems, it's a very step-by-step procedure. The first thing we want to do is we want to always draw a free body diagram. When we are drawing these free body diagrams, it becomes very, very important that we are able to identify all of the forces that act on the body. And when we're doing our reaction forces, we need to know the type of reaction force we have. So if we have this reaction force at A, this reaction force is going to become perpendicular to point A. And let me indicate point A right here. And if let's figure out what angle this makes. So we know that this angle, these are all angles. We know this angle right here is 30 degrees. So that means this angle right here is 30 degrees. These parallel angles right in here are 30 degrees because this angle is a 90-degree angle. That's the definition of that reaction force. We know that this angle right in here to the horizontal is 60 degrees. So I'm actually going to just redraw this just so it's a little bit cleaner. But I'm going to have a reaction force. This is 60 degrees, and let's call this my normal force at A. All right, and let me draw the bar. So the bar is going to be here. I'm going to have this 800 foot-pound. I'm going to have this other external force that points down this way. These are easy. These are the external forces. So this is a 5, 12, 13 triangle. 390 pounds. And then finally, I have this reaction force that acts at point B. Now, point B is a pin. A pin has two reaction forces. One reaction force is going to be up, and this is going to be this reaction force By. The other force is going to be to the right, and this is going to be a reaction force Bx. Now, the trick with when we don't know a reaction force, we don't know Bx and we don't know By, we want to assume positive. So if we assume positive and we solve and we actually find that Bx is negative, we just know that this reaction force points in the other direction. It becomes easier to deal with positive numbers than negative numbers because then you have minus signs you can have a better chance of making a mistake with. So when you don't know, assume positive. Now, these are all of the forces I have. So the next thing I want to do, I want to sum my forces in the x direction, and this is going to be equal to 0. Now, I'm going to say anything to the right is going to be positive. So here I'm going to have NA times the cosine of 60. That's this. This is a moment, so it's not a force. We ignore that. And we have this. So we have a minus 390 times 5 over 13. And then we have this Bx. So plus Bx is equal to 0. That's the equation I have for the sum of the forces in the x. Now let's look at the sum of the forces in the y. Anything up is going to be positive. So I am going to have Na. Let me write the whole equation. Sum of the forces in the y is equal to 0. I have Na times the sine of 60. That's this force over here. Then I'm going to have minus 390 times 12 over 13. That's the y component of this force right here. And then I have plus by. And that's equal to 0. So that's the sum of my forces in the x and the forces in the y. Now, right now, I can't do anything with this. I have 3 unknowns, but I only have 2 equations. So I need to go to the next equation. The next equation I'm going to pick, I'm going to sum my moments, and the point I want to pick is point B. Why point B is a good point is I have multiple forces, including 2 unknown forces, going through point B. That means these forces won't have a moment about point B. So if I sum my moments about B, I'm going to say counterclockwise is positive. This is going to be equal to 0. I'm going to first, let's start with my NA forces. I'm going to have some force in the upward direction and some force in the right direction. Both of these moments are forces are going to create a moment about B. They don't go through point B. If I rotate counterclockwise, both of these are going to rotate about point B, tail first. So these are both going to be negative. So I'm going to have minus NA times the cosine of 60. That's this horizontal component. The perpendicular distance is this distance right here, and that's 3 feet. So then I'll have minus NA times the sine of 60. The perpendicular distance is this complete distance right here, so that's going to be 8 plus 4 feet, so 12 feet. And I have this moment. This moment is going counterclockwise. I said my positive direction is counterclockwise. So I'm going to say this is plus 800. I do not multiply this by a distance because it is already a moment. It already has a unit of foot-pounds. Next, let's go on to this 390 force-pounds. When I break this up into x and y directions, well, this y direction goes right through point B. So it doesn't exert a moment about point B. The x direction is going to have a moment about point B. It's going to have this perpendicular distance, which is 3. And so I'm going to have plus 390 times 5 over 13 times the perpendicular distance, which is this 3 feet. So 3 feet is equal to 0. So now let's put this into the calculator and we can simplify this. So I want to come up with an expression for NA. I want to combine those first 2 terms. So minus cosine of 60 times 3 minus the sine of 60 times 12. And this is equal to minus 11.89. And we have our variable NA. And then we're going to actually combine this term right here and move it to the other side of the equation right here. So we'll have 800 plus 390 times 512 or 5/13 times 3. Move it to the other side of the equation, and we get this is equal to minus 1250. Okay, we can solve for NA. We can divide by a minus 11.89. And we get this is NA is equal to 105.1 pounds. When we look at this answer right here, this means this assumption was correct. We have that normal force that points in that direction. If this normal force was negative, then it just means that pointed in the other direction. But now, what we can do, we can put this 105 times the cosine of 60 minus 390 times 5 over 13th plus bx is equal to 0. We can solve this for bx. So 105.1 times the cosine of 60 minus 390 times 5/13 times -1, because we got to bring it to the other side of the equation, and we get bx is equal to 97.4 pounds. It's positive, so we're correct in this assumption that bx is to the right. Finally, we're going to do that here. We're going to get 105.1 times the sine of 60 minus 390 times 12/13 plus by is equal to 0. 105.1 sine of 60 minus 390 times 12/13. Move it to the other side of the equation, and we get by is going to be equal to 269 pounds. So those are our answers, and we're correct. Again, it's positive, so this assumption that we guessed up is correct. So by is 269 pounds in the upwards direction. Bx is 97.4 pounds going to the right. And our NA force is 105.1 pounds, and it's up 60 degrees from the horizontal. If this video was helpful, please consider liking the video and subscribing to my channel. This will help increase the visibility of my videos and help people who are struggling with this topic find the video more easily.